Fair warning, part of this tonight involves live coding and what could possibly go wrong. But we'll try it anyway. Here we go.
Living dangerously is a good practice.
Yeah, well, after a full day of meetings. Okay, that's not good. So, this talk is also weird. This is the talk I submitted to CPPCon. So, and you typically see a certain amount of this around here, like later in the summer. Everyone's coming here to practice their talk. So, thank you for letting me come here and give you the alpha version, right? Complete with bugs. This is a weird one in a lot of respects. It came from a couple of places, and it's really 2 or 3 different talks smushed together because that's the only way it worked. With apologies to the poet, this really came from a couple of places. My coworker, John Maloney, very and probably most valued coworker, he is arguably the best software developer at SciTech, who called shenanigans on me about a year ago, and I owed him a response, and this talk is the response. But also, Brian, did I get your, where's Brian? Did I get your last name right? Yep. We were at the pub after a talk, after one of these 3 or 4 months back. This topic came up. He got very excited about it and convinced me this is worth doing. And also, Scott, who gave a very similar talk, is Scott here, right? This is not unlike yours, same general topic, just a different take on it. And I need to look at your slides again because I missed something that I think you know how to do something I didn't know how to do. Okay. So, and damn it, it's a talk that isn't about unit tests, and every other talk I want to give a talk about that isn't about unit tests because damn it, I ought to be able to do that. So, all right, this all started about a year ago. So the way that our contracts typically work, we're a defense contractor, our customers typically write contracts to have financial incentives in them. And this is for stuff beyond just making it work and doing whatever the thing is. And these are to encourage behaviors beyond just make it work or meet the regs. And these typically get into things like, are you doing a good job of program management? Are you over or under budget? There's a bunch of stuff that goes in, but ours have had a lot of technical stuff. And last year, we knocked ours out of the park, which was really nice. One of those incentives involved having unit test code coverage across our code base at a certain various levels. We don't have to get into the details, but what they really wanted was to know that we were doing a decent job of software engineering. I hate to say it, but in our industry, that isn't always a given. No comment. But speaking of all-day meetings, but more than that, like SciTech, we sort of had to prove ourselves, and one of the things they want to know are you guys testing your code? Are you doing a good job of all the things that we think are best practices? So they wanted our unit test code coverages to be good. That's all right, fine. And by the way, we worked hard to get there because we had a lot of very old code, but also a bunch of stuff that had been thrown together really, really fast as part of a prototype effort. And we had to upgrade that in unit test and all that. So we actually did a lot of good work. So anyway, we're doing this. About a year ago, we're doing this work. And being the software lead for all this, I'm kind of looking, every couple of days we'll roll the numbers up and I'll see how we're doing. And I'll go pester the right people about writing their damn unit tests. And so I'm kind of poking around, and there's one repo that, everything in there, every function in there is at 90, mid to high 90%, the whole thing, except for one function, which had terrible test coverage. So of course I have to go look at it. Now, it didn't exactly look like this because SciTech typically doesn't deal with 5-letter mammals. But it was much worse. It was the enumeration had about 60 some odd elements in it, and they were POSIX error codes. And what the switch statement was doing was translating POSIX error codes from a library into a different set of error codes that matched another thing. Because we've got multiple libraries that do the same thing and they have to whatever, right? So it was ugly, right? And it was about 60 lines long. The switch statement was 60 lines long. The unit test was this. It had one line and it tested one of them. And it's like, okay, your unit test coverage in this is like 1 out of 60. It's like, okay, well, that's why it's bad. And Now, it was a Friday afternoon. I could have like, look, what would you all do? If you wanted, look, I got 10, 15 minutes. We might as well get the code coverage up. You cut and paste from the switch statement over to the unit test, and we all use Emacs, right? Okay. And you capture a macro that changes the switch statement into your unit test, right? Like, don't be silly. Of course, that's what. Of course. But you know, that's too easy. So instead, I recast it as a std map from mammals to, well, in that case, from POSIX error codes to the other error codes. In this case, we will map mammals to prime numbers. I'll explain why in a little bit. And now the switch statement gets replaced with a one-liner. Just look it up in the map. Unit test code covers to 100%. Victory.
Shenanigans.
Shenanigans. So the bovine source fertilizer is one way to put it. John Maloney, I mean, he is one of the best software engineers, maybe the best we've got, and one of his jobs is to call bovine source fertilizer on a lot of my crazy ideas. His concern, of course, was the runtime overhead. Our stuff is more or less real time, mission critical, can't fail, et cetera, et cetera. We got to keep up with the data, right? And these guys can tell you that this is not an easy thing. And we all know that std map is one of the slowest things in the standard library, so clearly it's a bad idea. He was worried about that, legitimately so. I was more worried about the fact that it feels like we're cheating. I mean, if I'm reporting this to the customer, and I'm going to say, oh, that function now has 100% code coverage, but the unit test still says what it said before. Where did the extra unit test coverage come from? The percent code, the code coverage numbers went up. Is this legit or is this a scam?
It's a scam.
We did not scam the customer. Even if this was like what, 60 lines out of about 2 million, so like, right? But this has bothered me for months now, right? Like, whence cometh the better code coverage numbers? So 2 parts to the talk. The first part is going to be a deep dive into the technical issues about how you write code that matches or tries to match what a switch statement does. And then the second part is a dive into sort of the philosophical, what the hell did we just do? And are we cheating? No, we're not cheating. Let me just, what's that?
Technically, you're not.
Well, technically, we're not, but even philosophically, right? We'll talk about it. All right, so typically in C++, you'll see mostly three kinds of switch statements. How many times do we see this, right? This is so old, we are so bored of this. This is silly, but we do it everywhere, right? You've got this all over your code bases. You know you have this kind of thing all over your code bases. Now, the good news is that this is going to go away, right? Give it another year or two. Give C++ 26 gets ratified and our compilers start implementing compile time reflection. There were 2 talks about this at CPPCon last year, and they were both highly recommended. This might not be the final syntax, and I think this only works on an experimental branch in Clang right now. I don't know if GCC is working on this. And we'll spend just a minute, but template type E is the enumeration you want to do. Requires that E is an enumeration. Const expert returns a standard string. The function is enum to string, takes an E. That's your enumeration. Template for, okay. Const expert, so we're going to do a for loop over std meta enumerators of E. This is a compile time, will be a compile time loop over all the enumeration values in your enum. And then we are going to emit this following code. If value, which is your function argument, equals, okay, I guess that syntax turns into the evaluate the enumeration, then it returns std string std name of, okay, look. In a year, we'll all be doing this, we hope, right? We know that this is silly, and we've known it for decades. We're not adding any useful information to the program. Honestly, when they introduced enums into C, which I think was the early 80s, they could have added something that lets us ask the compiler what the name of the identifier is and give it to us. right? We're really just working around a quirk of the language.
In the mid-80s, 640 kids.
Yeah, no, in the
Was a
mid-80s,
lot.
it might have been a big ask. All right, fair enough, right? Now, the second case, this is what we're going to talk about tonight, where we're really talking about conversion from your enum to values, whatever type. Here, we're just going to use integers because we're going to be looking at assembly code later, and the integers are easy. Could be strings, could be doubles, could be whatever it is, right? So here we are adding information to the program. Nowhere else in the program is stored the mapping from horse to one and camel to two and all this stuff. And the third, you'll see how many of you have this floating around, right? Where you're really mapping your enum to behavior. You've got code in it. So if the enum is a horse, you do something. You make the horse and you handle the horse. If it's a camel, you make the camel, you feed the camel, you argue with the camel, you do like whatever the logic is, you're mapping your enum to behavior, which is a fairly complicated thing. I will claim that nearly all the time you can and should refactor this. So each one of those is just a function call. This is cleaner code. Everyone agree that this is just cleaner code? You can now unit test these functions independently without having to unit test the switch statement at the same time. Or these could be really just a mapping between enums and function pointers. So it's just values that happen to be functions. You grab the function pointer and you call it later, whatever you want to do. This is kind of a strategy pattern. If you like design patterns, kind of a weird one, but it's that idea. Oops. All right. So we're going to focus on just mapping our mammals to integers because that's simple and the assembly language is easier to read. And we'll see this in just a minute. We're going to use prime numbers because optimizers are clever. And we don't want the numbers that we're mapping to be something that a clever optimizer can figure out how to compute from what we send in. Optimizers do that a lot, right? If they're prime numbers, it can't. So we ought to see the prime numbers in the assembly when we get there in a minute. So here's the point. Let's talk about what my colleague was upset about, which is the runtime performance. We know that StudMap is just about the slowest thing around. What about switch statements? Well, we know they're fast. These have been in C since the very beginning. So compiler optimizer writers have been optimizing these for 40 or 50 years now. So GCC in -03 will turn our switch into this. And I don't know assembly, although I learned some to do this. Over there in the assembly, this stuff over here, we'll just go through this real quick. EAX is the return value. So we're loading 97 into the return value. EDI is where the input parameters. This is mammals M. This is where your function parameter sits. So we're comparing the input to 15. JA is jump if above. So if EDI is bigger than 15, jump to L1 and return. This is the return 97 at the end, right? Okay, if EDI isn't bigger than 15, there's this weird thing here. It's a 64-bit architecture. The registers are really called RAX and RDI, I think. And these are the lower 32 bits of those, because the compiler is doing all this using 32-bit integers. So what's sitting in EDI, the lower 32 bits, is our input, our mammal, and the upper 32 bits are anything they happen to be depending on what the CPU was doing just a minute ago. So, and you don't want that, because we need to be able to use our thing as a pointer offset. So moving EDI to EDI, it turns out that's the magic way that you zero out the upper 32 bits of the register. So now RDI has really got the value of our enum in it. And then on line 6, it basically uses that to do a pointer offset computation. And it's going to look up the value in what turns out to be a lookup table. People have known this. This isn't new. I hadn't really physically seen it before. But this kind of switch statement ends up compiling into a lookup table. We can see the compiler has generated exactly that. So here we go over to Godbolt. This is what we just looked at. I would like to point out a thing that I only learned about a few days ago, but you might like this. utility. How many times do you have a switch statement where you know for a fact line 44 never happens? Can't happen. The semantics of your program is that you have a valid mammal and you know damn well you've got a valid mammal. And you don't care what happens if you don't have a valid mammal because you never have an invalid mammal. Or if you do things have gone so horribly wrong, you might as well just crash and start over. Right? Well, there is a thing called stood unreachable, which needs C++23. Whoops. Stood unreachable invokes undefined behavior. Now, if you know anything about undefined behavior, doing this sounds like the absolute worst, most ghastly thing you could do, except compilers are allowed to assume that there is no undefined behavior in your function, in your code. They assume that very, very hard. That's why actual undefined behavior is a bad idea. But when you put it in like this, that just tells the compiler that it can assume you never get to line 44. And if we look over here, now we have fewer assembly instructions. All it does is zero out the upper part of the register, look it up, and return. Yes, sir.
Why do we need that when there's so many easy ways to invoke undefined behavior?
I would say during a code review, you would like to invoke undefined behavior in a way that makes it obvious you're trying to and not doing something horrible. Also, it may be that stood unreachable has something special in it that tells the compiler it isn't really undefined behavior, just chill. That I don't know about. I don't know.
Okay.
But anyway, this will come up later. But if you're really, really, really runtime performance hungry, and you know that your switch statements can never get to that last bit, you save a few assembly instructions. Question?
If you also use unlikely,
Possibly. I haven't tried that.
I wonder.
Right? Yeah, like put an unlikely down there. I think it's still it still has to generate the code to handle it. It might do it in a way that I have no idea.
The difference might be between that being like definitely not versus unlikely.
Yeah.
Usually you also save a branch with
Yeah,
select,
right.
that helps your CPU out.
Right. It helps the CPU, branch predictors, and all that. Anyway, all right. Now, we're not going to look at the assembly code for looking up things in a stood map because we know perfectly well that stood maps are horrible and we don't want it anyway. But just for fun, let's benchmark it. We know that stood map is slow. How slow is it? So we go over to quick bench, we go over here and we find 19 times slower. I'm actually impressed. I thought it would be worse. Stood map usually has its data spread all over RAM. Accessing something that's right next to the CPU and hardware is typically like half a nanosecond or something.
Yeah.
Right? Going out to main memory is typically 100 nanoseconds, so it's a factor of 200 slower. This is only a factor of 20. It's because of the way we made the stood map, and compilers are good at this. Let me just show you real quick how these benchmarks work. Here's our enum. All this business here, we're going to set up a random number generator. We're going to set up a distribution to generate numbers that correspond to our mammals. And we're going to set up a vector of some size containing random mammals. This is going to be our input thing. Here's our switch statement, and then here's our actual benchmark. This is Google Benchmark, if you haven't seen this. Quick Bench, wonderful tool. What we're going to do is make 100,000 mammals, random mammals. In our loop, we're going to loop over them, look them up. There's our switch statement. And just because in real life you're going to do something with the result of your switch statement, we'll just add this up. It'll be an unsigned integer, so the compiler can't look at this and say, oh, you're going to overflow its undefined behavior or whatever. And then with all benchmarks, you need a way to make sure that the compiler doesn't notice that the whole thing is irrelevant and optimize it all to 0. So that's what we do up here. Down here, we do the same thing. Where are we? Yep. Here's our stood map. We look things up, and it's a factor of 20. The reason it isn't worse, as far as I can tell, is that the stood map is constant. And since we are generating everything in it from an initializer list, it's clever enough to put all the data in a contiguous chunk of memory. So at least once you've accessed the first of it, the rest of it is L1 cache. And the rest of it is cache friendly. So it's only a factor of 20 and not 200 or something. But this is silly. We know that this is slow. In fact, I think I've got, yeah, there we go. If you want more on why StudMap is slow and what to do about standard containers that are slow and which ones are faster, this is over a decade old now, but it's still a really good talk. Chandler Carruth, I think it was, it's what turned into CPPCon before it was CPPCon. So you can go look at that. Good thing, everyone should know. Now, we can do better. We all know we can do better. It's the Denver C++ meetup. Jason Turner and Ben Dean are our leaders. So we know what we're going to do, right?
Yeah.
All together now.
Oh,
Explore all the things. Of course we're going. We would embarrass them if we didn't. So this is stupid but simple, works. All right. So we're gonna bank on the fact that we know a priori that our enums start at 0 and go to 15. We'll fiddle with that later. So we're just going to put our prime numbers in an array in the right place so that you can use your mammal's integer value and just look it up. This is what we've got. So our compile time, get the mammal code. We check to see if it's valid. This works because these are unsigned integers. If it's greater than dingo, return our 97. That's our we didn't find it value. Otherwise, just look it up in the array. And QuickBench says that they're absolutely identical. Well, that's promising. Let's go look at the assembly. So over here, here we go. All right, this is what we started with. I'm taking the unreachable out just for fun. So this is what we had before. Move 97 into your return value, compare your input with 15. If it's greater, jump to return. Otherwise, do the zero out the register thing and look it up. Cool. Over here, here's what I just showed you with our context for static array of integers. And we just look things up. And if you look over here, this assembly is exactly byte for byte, the same as what you get out of the switch statement. Takes GCC to do it. Clang isn't as good. We know GCC has better optimizers than Clang does. The only real difference is that since we gave our array a name, our array name shows up in the assembly, whereas over here, the compiler had to generate it from scratch. So we can use a compile time data structure and under these conditions get exactly the same result. The resulting executable is identical. Question?
Can I say that I actually like the switch statement better?
You can. That's the second half. Well, that's the second part of the talk. And you can absolutely say that, and we may have to argue about it over a drink. Because the end result is I think I don't like the switch better, but I could be persuaded. I change my mind on a regular basis.
I do like the mappings right next to each other in source code. I feel like that's kind of easy to get an idea
Right.
of when I read it and add units.
I'm not saying you should never use a switch statement again. I'm just saying if you don't want to, under these conditions, you don't have to, and you pay exactly 0 runtime problem. Yes.
Just, it's been a while since I've looked at this assembly. The JA versus JG, is that just something the compiler chose as a standard, or is that a different instructor?
You don't.
You can hover
It's
over it.
jump greater as opposed to
Jump
jump.
greater and jump,
Someone who knows x86 assembly can
Jump above.
explain this.
They
jump
said
above,
that.
yeah,
Jump
jump
above, yeah,
above and
jump
jump
above, I
greater.
think is unsigned.
Oh, so it's a difference between whether it's a signed or an unsigned comparison.
Yes.
Oh, cute. Okay.
They set different flags, I think.
Mhm.
Well, that would make sense because mammals is technically a signed integer.
Right.
So it's doing the conversion in your comparison.
Right. Interesting. is it Conway's law that if you, it is, I don't know whose law it is, that if you have a question, you want answered on the internet, you do not go to the internet and ask the question. You go to the internet and put up a wrong answer and wait for everyone to show up and correct it. Right? I'm not joking when I say that I learned more from this group of people at the bar afterwards because they all tell me what I'm wrong about. Okay, let's keep going. So, all right, that looks good. That was easy. What if we just do something like our enums don't start at 0? We ought to be able to do this easy enough. Now, the switch, of course, that doesn't change. We're going to get a little fancier looking down the road. This might partly answer your issue. What we're going to do now is actually take the time to explicitly write out our mapping. It's still a const expr static const std array of pairs of mammals to ints. I like this better just because you now have somewhere in your code directly right next to each other. Here's the mammal, here's the prime. You can actually use it, I like it better. Right? Now, of course, having this, we could, given a mammal, we could just search through this, but we're not going to do anything that simple. So let's take a look at what we're going to do. There it is. Okay. Mammals, this is all our stuff. This is what I just showed you. This is our array of the actual mapping we want. What we need to do is turn that into a straight array of integers that we can just index into. So const eval, Jason was talking about this 2 months ago. We're going to make a std array of integers of the right size. We're going to fill it with 97s. That's our we didn't find it value. We will then iterate through this and load the correct prime number into the place corresponding to that mammal. That's a function. Const eval returns that std array. Then we just grab that array in a const expr thing, and then we've got the same lookup code. What happens? Well, if you do the switch statement, this is almost the same as we had before. This is what the compiler does with a switch statement. The difference is that now we're subtracting 10 from EDI, and then everything else is the same, except we don't have to zero out the upper bytes because apparently sub zeroes out the upper bytes of your thing. The same thing, we got our lookup table. It's not really surprising. Compiler just is clever enough to subtract 10 from our mammals. What we get is exactly the same code we had last time, but with an array that's padded out with 97s at the beginning. Not bad? Yes, sir.
But when you add another 5-letter animal that's after dingo,
Yep.
then
You would have to go fill it.
you have to go change the code
You have to go change the code.
because
Yeah.
the const eval function depends on dingo.
So the code that I'm showing, yes, the code I'm showing is not the general purpose solution yet. It's demonstrating the techniques work. But if you did this for real, and I am actually doing this in our code base right now, you would be much more careful about setting all this stuff up. I think I still have the slide where I do a better job. But yeah, this as it stands is good enough to look at the assembly, but it isn't the way you want to solve the problem. Absolutely. Can we arrange for our code to not just pad things out? Maybe we don't want the extra 10 bytes of 97s floating around. The answer is yes. And again, yeah, okay, actually, this gets partly to what you were just asking about. All this stuff is the same. Now I'm going to add a function, and we're going to run std min element. You can call that in const expr functions and const eval functions these days, which is nice, to find the minimum enum value. So I'm looking and comparing and looking for the lowest value of the first of each pair. We'll call that offset. We do everything we did before. We just keep subtracting offset from our thing. And now we'll be a little bit more careful, and we'll make sure that our array that we look things up in is the same size as our mapping. So this is better. Actually, this is still a little wonky, but again, it'll be enough for us to look at the assembly. And now we get, well, we got over here, this is what we had before, we subtract 10, we do the lookup. This is almost the same. I'm not entirely sure why we have this line here, but based on what people just said, I'm gonna guess that this is it's a signed integer in one case and an unsigned integer in the other case, and it has to do an extra thing.
Signed extension.
Is that what that is?
Yeah.
Move with signed extension. There you go. Right, so arguably,
If it's negative, you have to have that high bit set.
we did something like this, does it fix it? Oh, or,
It has to be a class, you know?
C standard.
oh, yeah, or something, C++ 23. Do I have to include?
C standard.
Oh, yeah.
Typing it live, what could possibly go wrong? There we go.
Oh, it's still.
Oh, now it's still screwy. All right. It's close. Now, question we're not going to dive into that much. Is our version with the constant expression blah, is it fast enough for you to replace the switch statement with this and upward? It's an extra 1, maybe 2 assembly instructions. If this is sitting somewhere in a tight loop, maybe that matters. I'm guessing 990 times out of 1,000, it doesn't. I can also tell you that taken individually, these things run so fast that you can't measure them very well. I'm not saying it never makes a difference. I'm saying if it does make a difference, it's because you're doing a good job of profiling something. So I claim that this is still an acceptable replacement if you decided to. There's other reasons to do so. We won't get into some of the other options. You can do negative offsets. You could set horse to -3, plus or minus signed extension. I don't know, okay. You can put gaps in the middle. I'll do that real quick. If we go back, like if I just do this. So we now have a gap in our enum values, and you can see that the compiler just has its array out with 97s. Okay, we could do that, right? Based on this kind of simple, crude, just example code, we're perfectly capable of writing something that does that, right? Okay, fine.
It got real creative though. It looked at your values and converted it. It's bytes now instead of longs.
Yeah,
That's interesting.
the optimizers are smart. Okay. Let's really get crazy. We'll just turn this up to 11 before we move on to other topics. What if you've got an enum where nothing is near anything else and they're scattered all over a wide range of values? I hit this yesterday in our code base. I was fiddling with this, seeing if I could put it in, and all of my kind of simple example code blew up because it was even worse than this. One of the values was something near like unsigned 32-bit int max -1. Gee, thanks a lot. All right. So if we have something like this, oh, first of all, what does the compiler do with it? Let's go up to the top. Here's our thing. If I turn the optimizer off, okay, now the optimizer's off. This is clearly slow, but the point is after some initial stuff, compare EAX with, oh, that's the horse value. Jump if equal down to L2. You know that that's going to do something in a return. Compare it again. Jump if greater to L3. Compare with 57, whatever it is. I think it's a bison, right? It sorted them. Okay. Basically, it is turned into the assembly equivalent of if it's this, return that. If it's this, return that. If it's this, return that. This is the equivalent of a big stack of if-else's. Cool. You could call this a linear search. Is it the first one? Is it the second one? Is it the third? But we all know that most of the time you can do better than a linear search. Oh, I will point out though, there's one place where linear searches will kick the bejesus out of any other algorithm. That's if you happen to know that one of these values shows up most of the time and you put that one up front. A linear search that always finds it on the first or second try will scream compared to just about any other option. Worth thinking about. But we can do better. So can the compiler. This is cute. -03 again. Takes a minute to see what's going on. Let's compare 28, 28, 24. That's the otter. Jump of equal to L6, jump of above to L3, compare with 6, 4, 28. That's koala. It's a binary search. I think that's impressive. Well done, GCC, right? This is, if you go down and look, this is, all right, we found our value, return it. The jump aboves are, the value we want is above where I just looked. So do the upper half of whatever you've got. And then what's left here is do the lower part. Now, we could go implement that in a const expert thing, probably get about the same thing, right? We've established we can do that finally. But we do better. Like even in principle, what's faster than a binary search? How about a hash maps? What if we did a hash map? Now, hash maps are complicated beasts, right? Because you have to deal with hash collisions, right? If we came up with a hash for these numbers, we would have to worry about what happens if two of these happen to hash to the same thing. You've got to have all this extra machinery to see, well, you know, a zebra hashes to the same thing that a koala does. So if we get one of those and we find, oh, is this the actual thing for the koala? Oh, it isn't. We've got some algorithm to search for where the other one is. In this case, we would also have to deal with collisions between invalid values and these. What if someone throws a random number in, but it happens to hash to the same thing as an otter? We're going to get the wrong answer. We're not going to get 97. Writing all the code for that is a pain. We can do it. I mean, it's not hard, but it allows you to try to do, as an example, live demo with all this stuff. But just imagine, what are the chances? What if it just so happened, by some strange coincidence, that we knew of a perfect hash for these numbers? A function that hashes these down into an 8-bit integer, and for this particular set of values, there are no collisions. What if, by an even more staggering coincidence, we don't care about what it does if we send in an invalid mammal, because we're not going to? Which means that our hash map is really simple and we can put it up here. What are the chances? 100%, because I cooked this up exactly to do that. So if we go down here, this is just about the simplest way to hash a 16-bit integer into an 8-bit. By a strange coincidence, these are all in the range of unsigned 16-bit integers. Amazing how it works out like that. And all we're going to do is XOR the high bit and the low bit, high byte and low byte. And then go carefully choose all those numbers so it works out. We will make our lookup table, just look, we know that it's an 8-bit unsigned integer. Let's just make it big enough to handle all of them. 256, fine. We'll have 256 entries, and we'll put our prime numbers in the hash of the mammal value. To do a fair comparison up here, oh yeah, we got the stood unreachable, so we don't have to worry about it. Very, very simple hack map. Also very unlikely to be the correct answer in general. Like, this is not a general purpose solution. But it ought to be faster, right? How much faster is it? The blue is the switch statement. Our hash map is 3 times faster than a switch statement. Given how much time people have spent optimizing switch statements, I think this is fairly impressive. But of course, this is unfair, right? You wouldn't expect a compiler to come up with this unless you're going to let the compiler sit and look at this for a couple of hours. Compilers are not going to go search all known hash functions to find the one that's perfect for your thing, right? We knew something the compiler didn't, and we parlayed that into a better data structure. I still think this is pretty impressive. So let's just sum up. Given a certain amount of work and a certain amount of fiddling, we can recast pretty much every switch statement you've got into some kind of compile time map, if you wanted to, with at least very comparable runtime performance. Exactly the same in many cases, and faster, notably faster, in special and particularly unlikely cases, but we have an existence proof that it is doable. You can do it if you're lucky. So switch statements and compile time maps are essentially isomorphic, plus or minus a little bit of performance, a few extra assembly instructions here and there. Depending on how picky you are about your performance, they are exactly the same, and in some cases, you can't tell the difference. They are byte for byte the same. We've sort of known for a long time that switches are really just lookup tables and computed go-tos and basically compile time maps. This isn't news. No, we just made it obvious. Question?
We tried using the standard library as Hirschman unordered now.
I don't think you can use that const expr yet. Although I suspect that's more just they haven't put it in the standard, or the GCC developers haven't built it. I don't think there's any reason why it couldn't be. And if you could, and if they did a good job, you could probably use that. If it existed, that would have been the first place I went. Because doing all this other stuff, also, it actually does all the correct hashing, which means I don't have to carefully cherry pick my example and come up with unreasonably fiddly examples.
Hey, Dave,
Yeah.
given the fact that sequential enumerator values are friendly to the compiler, do you think it's fair to just say as a blanket recommendation that you shouldn't go giving specific values
Yeah.
to your enumerators? Just
Yeah.
leave them default, don't even equal zero,
Well, in fact,
just name them, comma, move on.
let's take a quick interlude and go back and look at what happened, which is your question. Uh-oh, wait a minute. Now, see all these hands go up? This is where I start learning things. Yes.
Unordered map would have the same problem as vector in, you were to make it const expr because it requires allocation.
Right, but can't you allocate? Oh, you can allocate memory in const expr, but the results of the const expr can't have the allocated memory.
It can't escape the scope.
Right. So you might be able to use a std vector to make something, but you can't end up with that in your code. You're right.
The unordered map is not supported right now.
Right.
But in theory, you could write a paper and submit it and
Yes.
maybe get it through, but it has the same problem as vector.
Right, you have to be very careful with const expr stuff that allocates memory. Yeah, that's the problem. Wait, hang on, okay, yes, Brian.
At the beginning of this talk, you said you were using time numbers
Yes,
to work the optimizer for switch statements.
yes.
I'm curious if some of those tricks worked for the cases that were identical. In other words, when you gave it a context for array,
Yeah,
would the compiler invoke the same tricks that it could have for a switch?
I have no idea. Just as a bit of context, we could spend hours looking at all the different variants of this, which I'm not going to because we're going to go on to the next thing. But I want to assure you, I have spent far too much time fiddling with this. Now, something I do intend to do, it's actually what I was working on today while I was listening into an all-day meeting. Don't ask. I ought to be able to come up with a reasonable implementation of this that is much more generic. You just make an enum, do a thing, and you get all this. And it's smart enough to say, okay, they're all packed together, I'll give you this. They're not quite packed together, I'll give you that. Holy crap, you better give me a hash function. I don't know, we'll see how far we go with it. Because I can tell you that we've got this stuff all over our code. I can't tell you how many of these we've got. And there's at least 17 different ways that people have done this, aside from straight up switch statements, for reasons that we will never know. Well, get blame. I could go find out, but I'm not going to. And I would love for people to stop, but if I want to give them a better reason to do it, and I do think there are good reasons to do this, I'd like them to do it cleanly. So with any luck, I put something like that together and have a library I can give people. And then you can critique it and make it better. So, yeah, yes.
Just so I understand, all of this is because it takes a long time to write the unit test, putting every.
Yes.
Okay.
Yeah.
Because there's nothing actually wrong with the switch.
No, the switch statement is fine. I'm not saying don't use the switch statement. In fact, the fundamental question I've got that I do not honestly have I don't have a definitive answer to is whether you should ever do this. Which is what we talk about next. All right. So here's a bunch of benchmarks. The blue is the original hacked, horses 0 all the way up to 15. Doesn't matter whether it's the switch statement or our version because they're identical. The pink thing is where we added 10 to horse. And this is the switch statement, although I don't think you can tell the difference with the other one. It's one assembly instruction. That green is the binary search, and then the purple is our hash map. The point is that we have now just reminded ourselves of something that we have all known for a very long time. Because switch statements are compile time maps. Algorithms and data structures matter. Do you think? This is not news, right? We knew this. We just learned it again. The implementation of your data structure matters. The layout of the data matters. The data you put in matters. This is to your point about shouldn't you prefer to have all your enums be consecutive because the compiler can generate better code? Absolutely. If you put challenging data in your data structure, it'll work worse. Order, okay, like std map, whatever, right? Binary tree, insertion is log n, lookup is log n. And then if you go look back at your computer science textbooks, I'm a physicist, I only have one of them, but if you go look at it, it's all, well, this is the average case. And then you get, oh, the worst case for a binary lookup is order n because you inserted them in ascending order and your binary tree only ever has one thing on one side of it, right? Like this, I have seen that in production code that I wrote and found out about it later and just fixed it because I didn't want to get it done. The point is the data you put into your data structure matters. Some data sets are more challenging for a given kind of data structure than others. And error handling matters like queuing. And this is a topic I am not prepared to talk about tonight because it's also something that raises existential questions about our entire industry. If you can shave some time off an important loop by not checking for an error, but you know for a fact that error never happens, is that legit? How sure are you that never happens? We did this not too long ago. Someone was doing something like this, and it looked like an error was happening and was never getting caught. And I went over and groused at him, typically late at night, but that happens a lot. And it took the guy a while to come back, and he's like, look, we have been using this library for years. This has never happened. I'm like, okay, fine. But I want some evidence, right? Pete Muldoon over at Bloomberg, I talked to him at CPPCon a lot. He's got stuff that does this. It's like you look at that, it's like, really? Are you sure that error never happens? Yeah, it's been in production for a decade, and we've never seen it. Is that safe? Practically speaking, yeah, maybe. You guys are looking at me with the same kind of skepticism that I feel. I mean, look, I believe you, but shouldn't you rewrite the, but we just saw that you can save a couple of assembly instructions. If that's important, right? If shaving those couple of assembly instructions off an inner loop is going to save your data center $5 million of electricity a year, that is an existential question I'm not prepared to answer until after we've been at the pub for a while.
How much does it cost if that?
Exactly, right? And I want to get to the other existential data, the other existential question that we've got. All right, so here's the second part. Should we do this, given that we can? Well, there's one obvious advantage that switch statements have right now, which is if you got an enum, and you have a switch statement that does all the enums, but you leave one out, compilers are smart enough to warn about it, right? They're kind enough to say, hey, enumeration value moose isn't here. That's nice. I don't know how to do that with a compile time map, but Chris might, because I think you did something last month that wasn't too far away from an ability to do this. But I don't remember how you did it. And so I got to talk with you about that later. Like maybe under certain circumstances with some assumptions and some fiddling around, maybe you can do it. I'm not, maybe, okay? But switch statements do that out of the box. But I will point out that we've already seen a lot of advantages to a compile time map, which is it's a damn data structure. So your mapping can have algorithms applied to it. You can find the first, you can find the last, you can iterate over all of them. How many people have seen this? Whoops, there we are. Ah, right there, sitting at the end of an Enum. Right? Yes.
The word count is 5 letters. It was
Yeah. Place I used to work, medical device company, which was just enums everywhere. And every single one of them had a last value, so you know how to set your loops up. Right? This is just annoying. You don't need that if you set these things up as compile time maps, because it's a data structure and you can iterate. You can use standard algorithms. That is a really useful thing. Because otherwise you sort of can't get your hands around enums, or at least not until we get C++26 compile time reflection. All right, so it's an advantage. Compile time maps have an advantage. All right, fine. But the real question is, what the hell do we do about these unit test results? And damn it, I was going to give a talk that wasn't about unit tests, and we're back to unit tests. I can't escape them, right? The fundamental thing that started me down this was that we had a big switch statement, and the unit test was one of these. And I switched it to a compile time map. Well, it was a runtime map because it was a Friday afternoon, and let's just see what happens. And our unit test code coverage results get great. Am I cheating? Is it legit? Okay, so just to put it up here, we have 2 implementations. Given that unit test, the original switch statement, I get 1 out of 16 or 17 lines of code coverage. I cover exactly line 8. For compile time map, I hit line 3 because we are going to check that conditional. We're going to take 1 branch, go to line 5 and do that. I have covered 2 out of 3 lines of code and half the branches with that same unit test. Our unit test coverage gets better. There's no doubt of that. Have I earned it? No. Did the tests get better? Is our code more carefully tested? Is the quality of the code higher?
No.
My colleague here is absolutely just saying no to every one of these.
I mean,
Yes.
is the test really better if it's just checking that the switch statement returns what the switch statement returns, right? Like what's the actual test implementation for this? It's the exact same.
Give me about 2 minutes. That's the point, right? Yes.
You also took code that was in one place and put it in 2 places. So now I have to look at more code
Yeah. So
when I review this.
Unit tests need to reflect the functionality, so they look similar. It's just that they're on the far side. Sorry.
3 minutes.
2 minutes.
No, you guys are exactly right. That's the point. So after a lot of fiddling around and figuring out how to discuss this, to drive the point home, let's see what we have to do to take each case to 100% code coverage. What does it take to get to code coverage the legit way in both cases? For a compile time map, all we need to do is add another check, another test case for the mammal isn't there, right? If we add line 6, right down here, we add line 6 and 7, right? Let's make sure that dingo plus 1 gives us 97. We now get 100% code coverage. Hooray! How did we earn that? Well, we did add information to the unit test. We added a test case and some comments. Okay, fine. But we added a test case that exercised something we didn't exercise before. There's more information in the unit test than there was before. Where did the information come from? There's 2 places it might have come from. First, from doing what we did, you examine the code, you notice that there's a branch you missed. Okay, white box, it's not white box testing, it's white box analysis, but fine, you go look at the code, oh, we missed something, we add that test case, you're done. The other place it might have come from is wherever the heck this mapping came from in the first place. Presumably, if you've got this code, you have some spec or some requirement or something that specifies how you map 5-letter mammals to prime numbers, right? Whatever that spec is told you what to do if you couldn't find the mammal, or you wouldn't have written this code in the first place. So you look at the spec and say, oh, we'd better check the case where it's not a valid mammal. All right, that second case is a test oracle. This is the hardest, one of the hardest problems in testing, particularly unit testing. Where do you get your test oracle from? Your test oracle is the place you get the right answer. So in your unit tests, you go consult your oracle to get the right answers you put in your unit tests. Most of the time, we're writing the code because we don't know the answer, and neither does anybody else. That's what the code's for. So how do you get a test oracle? That's a big question, which we do not have time to delve into the psychology and philosophy of that. But the point is that generally, a good place for a test oracle is the spec or wherever this all came from in the first place. We'll tell you something. All right, let's go do the same thing for the switch statement. To get to 100% coverage here, we clearly have to type in or arrange for us to have all the other test cases in our unit test. This is what a bunch of you have been waiting for me to put up, right? Damn it, you should do this. I think. What information did we add to the test? The entirety of the mapping we added to the test. A lot more information, there's a lot more typing. Where did that information come from? Well, maybe it came from the test oracle, that as you went back to your spec and typed all that in very carefully by hand, in which case you were providing a certain amount of value because at least you're detecting whether you made a typo. Like if you didn't type it into the switch statement the right way, if you got some of them switched, if you type it in again, maybe you won't make that same mistake and your unit test will catch something. That's possible.
You could make that test smaller and capture a similar amount of coupling to the first one. If you just wrote it as a loop that checked that
Every possible enum
value
gives you a number.
was
or
not
something.
97 or something.
You could do, so that's a property test, right? Just a different form. What you would do is basically write a unit test that says, for all valid mammals, I get something other than 97. It's kind of a property test or something. Test oracles, by the way, are frequently also found in approximations. I don't know what the actual answer ought to be, but I know something. So for this, we could, for example, have it isn't as accurate a test oracle, but it's more reliable in other respects, that says, if I send in a valid mammal, what I get out will be a prime number. I don't know which one up front, but it'll be, if it's not prime, that's property testing or things along those lines. Yeah, you can do that.
I've written a lot of tests like this, and I do feel a little silly when I write them. Admittedly,
Yes.
but, I treat them as basically approval tests, where if you want to change something about the underlying code, you have to change it in two places, which makes it more visible in a code review or more visible to the developer. So I feel like there's an aspect of intentionality, like it makes you more intentional and more purposeful with your change, because
Hold that
you
thought.
said, I'm not just changing it in one place,
Yes.
I'm changing it in two. I
Yes,
definitely want to do this.
yes. Whether that's a bug or a feature
Yeah, I like it.
is a philosophical point that we'll get to in about 3 slides. Hang on, let me go on. So we could get this from the test oracle, right? Like we go look at the spec and we type all that in, but you know perfectly well that's not what's going to happen. We have Emacs for a reason. Okay, Vim, if you insist. Yes, code. Yeah, you're wrong, but okay. You know perfectly well that you're going to go cut and paste the code out of the switch statement into your unit test, and then use your editor to go do something and turn them into tests.
You wouldn't if it was test driven.
If you were test driven, you would have written the unit test first, and then you would have cut and pasted that and turned it into. I mean, come on, but seriously, carpal tunnel is a thing. We don't have time to type all that. No, my point is that in real life, this is probably what's going to happen. It's how I made all these slides. I'm not typing all that again. Now, here's the point. If you do a cut and pasty thing, you're basically saying the test oracle is the code you're trying to test. If you do this, you do not have a falsifiable physics experiment. You do not have a valid unit test. That test will never fail until under maintenance. We'll come back to that. Hang on, right? And it's worse than that. All right. I like Dave Farley on this. Congratulations, you've just proven that the code you wrote is the code you wrote. This is not valuable, and it's even worse than that. Because it provides no useful testing, it increases your maintenance burden, which is the other half of what you said. You might like it to be in 2 places because you have to intentionally change it the same way in both places. So you have to be careful. Or you have just doubled your maintenance burden. Those are both true at the same time. Which one you happen to think is the case is up to you. You might think they're both. I don't know.
I think that you missed the point it being test driven. If it was test driven, you don't test declarations. And Enum is a declaration, so you'd have to have some kind of behavior that's exhibited. So you wouldn't have written any of this.
Right.
Like none of this would exist.
Okay, we now have an existential crisis that says we didn't need the unit test at all.
No.
We needed some other unit test doing some entirely different
Some
thing
other behavior.
that would have exposed these behaviors. Yes.
Well,
You understand that this has been keeping me up for months, okay?
it's one thing to test a switch that invokes a bunch of behavior
Yeah.
depending on the value.
Yeah.
It's another thing to test that the map from this enum produces this set of values.
Yes. All right, that's what I'm getting at. All right, real quick.
Yeah, I
All
think
right, okay, so. All right, so after much thinking about this at 2 a.m, I come to the very obvious thing that you've all been waiting for me to say probably, is the difference here is that we're doing two radically different things. When we write the unit test for our compile time map, what are we testing? We're testing the code that exercises the lookup. We've got some code, we've got some logic that says if it's greater than this, we return the not found value. Otherwise, we look something up in an array. That's code that implements a data structure. We are testing the implementation of the data structure. We are not testing what's stored in it.
Correct.
Right? But if we do this, we are testing exactly and only the data that's stored in the data structure. You can't unit test the implementation of your data structure because that's the compiler generating assembly code, right? Trying to unit test that is just silly. That doesn't make any sense at all. So the point is that in these different cases, in one case, we're testing the implementation of a data structure, but not testing what's in it. In this case, we're testing what's in it because there's nothing else to test. We're supposed to write unit tests. You can't unit test the implementation of your data structure. That's the people who write the compiler unit test that this is the assembly code that comes out, right? So we're doing two very different things.
So
I know, I'm driving people crazy.
I think you and I have discussed this at length before, but it doesn't matter if it returns the right value or not. It matters what the user of it does. So like,
Right.
That's what I'm saying. Like this doesn't do anything at all.
Right,
Testing
dude,
the switch
writing
statement
this test case
is not relevant.
is not useful.
Yeah.
But we all want it,
Because it's a
but it
declaration.
doesn't do anything.
Because it's a declaration.
Yes,
The whole thing's a declaration.
yes.
And you should never test declaration.
When he agrees with me, I know that I'm onto something that's at least fairly safe. Because you're better at this than I am.
But the thing is, it looks like, it acts like something that's done work.
Yes.
That's
But
the
it hasn't.
problem. Inside
Two
the black
slides from
box,
now.
we don't know.
I'm feeling better about
So
this.
we just need to change G coverage to say that you have the coverage. That's where the book.
All right, so look, here's the point. Static data, which is stuff that you bake into your code, or maybe it's just files you read and load up. Like when you start your program, you read some configuration files. You don't unit test that. The whole idea is just silly. You don't write unit tests for your configuration files. You've got an internationalized GUI and you've got lookup tables for the strings. We do stuff where we have to do a lot of time computations. We have to deal with GPS time. So we get GPS rapid files, which have got the list of all the leap seconds that have been added, and that's the offset between GPS time and UTC time. We have to read those at startup, so we do all our stuff right. You don't unit test that, right? I mean, the people over at the International Earth Rotation Service are pretty good about this. The code that reads them in, you'll unit test. The code that uses it, you'll unit test. Yet don't unit test your data. But if you take this to its conclusion, it gets even sillier. If you're building a GUI and you've got a bitmap that's supposed to go on a button, you don't unit test the bitmap, right? You have something else that you might have an automated thing that runs your GUI and you take snapshots and check that all the pixels are, I don't know what you probably do. You've been working on it. How do you test that? I don't want to know. So this is exactly to your point. You test all this data by other means, by the behaviors that depend on it being right. You check those behaviors, and that's how you decide whether you got the right numbers in the right place in your data structure. Is that a fair, crude,
Yeah.
but simplified statement?
So, yeah, I mean, it's, you would, if you did this like in a purely test-driven way, if you ever used horse,
Yeah,
you would put horse in the data structure, and there's some other test
right.
that is testing that it got it converted it to the right thing because the behavior of that function.
Is correct, exactly.
Not that you were able to look it up. You don't care whether or not you were able to look it up correctly, because you must have been able to, because the other thing did it right.
Yep.
And if one of those values was never used, it would have never been put in the Enum in the
Right.
first place.
Right.
Because just because it's in the spec doesn't
Mean that you ever actually access it.
put in there. So then you still have 100%.
Right. It doesn't, from that point of view, you've got 100% coverage. You've never checked that whale is 37, but if you don't have any whales in your program, you don't care?
You have implicitly, you check.
Right, exactly.
Because you fed it some data and
Right.
it converted to 37.
So-
And you know that it did because the other function worked.
Right.
Not,
Right.
Yeah.
So compile time data structures are weird in the sense that they occupy the space that we're not used to. I'm not used to. Some people are, right? Where it's code, but it's data. But it's code, but it's data, right? So if you write a compile time data structure, of course you unit test the implementation of it, including compile time unit tests, which are a thing and are a lot of fun. You can benchmark it, but as we just discussed, testing that the right data got put into it at compile time is of, at best, questionable value. I won't go as far as to say no value, but questionable. As an extreme case, if we went back to mapping enums to function calls, that's a hard thing to unit test, right? Because you either have to mock out the function calls, send horse in, and check that the horse mock got called, because that's what mocks are for, it tells you if they got called. Or you have to send a horse in and look for side effects in the whole rest of your program that indicate that a horse just showed up. Which, if nothing else, is not a unit test anymore. That's like a subsystem test, or I don't know what it is. I'm not saying you don't do it. Maybe it's the only way. So let me just start to finish up. Obvious conclusions that I think we could all agree on. They're both good. There's some trade-offs. Switch statements have some better errors. Compile time maps are data structures. You can iterate over them. Maybe you like that. I actually find that to be very comforting somehow. I can iterate over it if I want to. I'm going to come down, kind of. Compile time maps are mildly preferable. It seems, particularly if you're mapping whatever's to function calls, that this is a better way to go. Let's see if we can come to a conclusion about this. Wait, hang on. Yeah, Phil.
So what you're arguing is we shouldn't use switch anymore.
I'm arguing that we might prefer not to, not that you can't.
Sure.
But, and by the way, again, I am on the fence on this in a lot of ways.
I think you're arguing you
there was
don't test switch data.
There's a comment on mine earlier that I agree with, which is using the compile time structure, you've lost the ability to make sure that your declaration of enums to values contains all the enums.
Yes, so
you
that
could-
is
you
true.
could solve that compile
Right.
time, but you have.
That is true, plus or minus. Again, some of the stuff that Chris showed us last month when he was talking about similar things, I think there are some fancy things that you could, he had some very, very clever, I won't call them hacks. They were clever ways to do things. You might be able to if you did a whole lot more filling. I didn't want to go and discuss those.
You would need that
implementations.
before you
But-
switch, go ahead. Switch.
Yeah, but the switch statement gives it to you for free. I mean, legit, that's an advantage of the switch statement.
Assuming you do that running now.
So back to your data-driven thing.
Yeah.
If we were reading a file that contained a map
Yep.
of the enum value to like back
So,
to
yeah,
the
right.
POSIX value, right?
Right,
We
sure.
have the POSIX error code.
Yep.
We have a map
Yep.
that's in a data file.
Yep.
I would totally agree with you. But the fact that that is in code, it's imperative, not declarative.
Yeah, right? Is it cheating or is it legit? So look, we can test the data or we can test the data structure. When I do this, am I cheating to get 100% or at least higher, right? Remember, this whole thing started in this big thing. We had, the unit test that tested one of them. Our unit test code coverage was, 2% or something. I switched it over to a map. That same unit test, without changing it, now gives us 70% code coverage, which is good enough for our incentives, and we're done. Is this cheating? Is it cheesy? So it certainly feels lazy or cheap or something. It feels like we're gaining code coverage numbers out of nowhere. Now, look, we know code coverage numbers aren't really the thing. It is an objective measure, and it's strongly correlated with having good code. That's why our customer wanted us to do it. But there's measurement error. There are things that, lines of code that your thing can't tell that you executed, right? It's imperfect. Maybe we just found a way that it's really imperfect. I don't know. We could have tested all that. We could have put all those in. We just decided not to. So from one point of view, it feels like we're dumping the hard work of making sure we got the data in correctly onto someone else or some other place. Feels lazy. Maybe I don't like it. But doing it the other way, we've just discussed, is a waste of time. We have increased maintenance costs, or I have to say, right, we have made it more intentional. You might like that. That is an absolutely valid point. If you're going to change it, you're going to make sure you get it right because you have to go do it in two places. Yeah, that is valuable.
Part of it depends on where did that
Right,
originate?
exactly.
If that's in a spec that you have to meet.
If you retype it from a spec, it's valuable. If you cut and paste it from your code, it's a waste of time.
Right.
A year later, you can't tell.
If there is a spec
Right?
that requires those mappings to be
Right.
that way,
Yeah.
then you absolutely have to do all of that.
So at best, we are testing that we typed the data incorrectly. Phil is arguing strenuously for this. At best, we have done that. At worst, we've made a non-falsifiable test that just increases our maintenance burden, but it looks good and convinces you that you are doing something useful when you're not. My personal call today, last week, is that my heart wants to test the data, right? Part of me just feels like I want to go put all the values into a unit test. Like I want to. It looks right, feels right. But my mind says it's a waste of time. Right now, I'm saying the compile time map wins and you should do it that way. Don't bother to write a unit test with all those values in it. I know, Phil, but that's where I am right now. But again, I have been arguing myself back and forth between these points of view for months.
Can you go back a slide, please?
Yep, except, well, all right, go back a slide. Yeah, here we go. Yes,
2 slides.
2 slides.
Okay, you never defined EC. I almost remember what.
It's because all day meeting and I didn't have a chance. EC is an equivalence class.
Right.
I wasn't going to go into this because I wanted to make it shorter. Equivalence classes in testing are a set of values that you can send into a test and they all do the same thing. Either they all pass or they all fail, but they'll fail for the same reason. So when you're looking at your code and you're identifying paths, right, you want to get all of your code paths, what you're really doing is equivalence class partitioning. You're identifying all the inputs you can send in, right? There's a certain set of inputs that will make this condition true, and then something happens. A certain set of you can send in that make this condition false, something else happens. Those are equivalence classes. The talk I gave at CDPCon last fall talked about that some, and the one I gave 1 or 2 years before that, I went into a lot of detail about how all this works. If you really want to make sure that you are being thorough in your unit tests, you should do equivalence class partitioning, which is what we're talking about. And so when we do it this way, there's 2 equivalence classes, one of the values that are in and one of the values that are out. But in the other case, you've got an equivalence class for each enum, which is what you're about to say. You're going to claim that each enum is an equivalence class that must be tested.
That's right.
That is your point.
That is my point.
You're not wrong. but I also disagree. Right? Like I said, my call today, right now, is I like the compile time map better. We reduce the amount of code. The reason we get better code coverage is that we have less code to cover. Just philosophically, that's a win. I think it's a win. You can argue the point.
But you don't.
And we are expressing our data structure as a data structure. So, okay, yeah, there's lower maintenance burden, or maybe you prefer that. I mean, again, I take your point. We can iterate over it, but if nothing else, we are expressing a data structure, an associative array of some description, as an associative array, right? Philosophically, like there's got to be some deep-seated principle that says we win if we express the thing like what it is. Like I said, today, this is where I am. Tomorrow, maybe not. Your call, I don't know. Discuss over drinks. Thank you.
Can I ask a question?
I don't know. Yeah, go ahead.
So I generally agree with the idea that you shouldn't be testing declarations.
Yes.
So you don't need to be testing that values of certain enums or enums have certain enumerators have certain values. In the context of working professionally in closed source, yeah, the kind of saying we're just going to write some of the tests on all of them. That's generally fine because your users aren't really adversarial. At least you hope not. In the world of large scale library development, you kind of do have to assume your users are going to be somewhat adversarial, not intentionally, but I think you know what I mean. They're going to try stuff that is very creative and unexpected. And I've found that there's actually value in testing things that are just declarations. I have code that's it is just one of something in a header is just a constant. And I test that the constant exists with that name, with that value in the tests. And you could look at that and say like, that's kind of pointless. You're just testing a declaration. But the reality is that is something that users will use. And if we forget that, we might change the value and not realize that, oh, actually users were depending on that. So it becomes somewhat philosophical also of, does the specific value of that constant constitute part of your API, or is it just the identifier as part of it? In our case, we say the value is also part of the API, and therefore we test it. But that kind of goes in the face of what some others were saying in the room about never testing declarations.
So, by the way, that's also Hiram's law. You all know Hiram's law?
It's
You know Hiram's law,
right? Yeah.
right? Hiram's law, as the number of users goes to infinity, the chances that every possible observable side effect of your code gets used for something critical goes to unity, and then you can't change anything without breaking it. And then the relevant XKCD is the classic one about someone fixes a kernel driver in the keyboard, and you break an Emacs user who was counting on the fact that their space bar was heating up and detect something and configure Emacs, right? So that's true. And I will point out, as far as adversarial users, in our industry, this is unusual. This is a growing thing. We give our code to the customer. It's not our code. We keep copyright. But our customer gets all this. They can do whatever they want to with it. So that's not an adversarial user, but that's why they look at this stuff. But also, in a case where you're building critical infrastructure, the insider threat is not something to be ignored, right? So you get into all kinds of other issues there, which I'm also not prepared to talk about. But it might be good to have a unit test that checks that all your constants are still the same thing you thought they were. Writing a unit test, I don't know, maybe you make a text file that's got read-only permissions and it's in a different Git repo. And you compare the contents of your compile type data structure with what's in that somehow. Like it's harder for them to get to. I don't know, right? This gets very deeply philosophical. Like I said, I can argue myself into both ways. My conclusion is that I kind of like the compile time data structure. That slide was made 9 o'clock last night. That's the mood I was in. You can argue it both ways, Tyler.
You won me over with the idea of separating the data from the behavior and testing the behavior of your code. But I think you could go one step further in that you need to pass in the data structure as a parameter, and then you have a function that is more useful than being directly coupled to the data structure.
You can write this code. If this was sitting in the standard library or Boost or someplace like, you know, a really good solid open source library, you would expect a whole lot more machinery to be put around this to make it easier to express your thing. And
I mean, your data structure
Yeah.
could be a template parameter.
right,
but it
and
needs to-
and
it needs to
yeah,
be a
all
parameter.
this stuff which would give you control over the layout and also potentially allow you to, for example, iterate over, like, okay, what if you, instead of explicitly writing out every enum in your unit test, what if you iterate over it and spit the results to a file? And you know what that file's supposed to be, and you keep that someplace and you compare what's in the file. And whatever, right?
I think
Like,
it'd be easier.
that would still be checking every value is in there in the right place.
I think it'd be easier to sell people on the idea of it if you parameterize the function.
To be clear, I'm not trying to sell people on anything. This is a whole bunch of really nice techniques that you should know about, might come in handy. I don't know which one to go use. No.
I have an online question.
Oh, online.
question.
All right, online question. We probably do have to get out of here and actually go to the pub at some point,
So
fairly soon. Yes, online question.
online asked, or pointed out.
Yes.
I'm just going to
Yeah,
read it.
yeah.
Maybe he can unmute this.
I mean,
No, go ahead and
I
read it.
think he
It's
tried to talk, but we
yeah.
didn't hear. it.
Yeah,
So
yeah.
Anyway, I'll repeat the question here. And Paul, if you unmute yourself, I think we should hear you, but I'll try it here. My background is in Object Pascal. We have pure enums. I don't know what that means personally.
All right.
I guess that is isomorphic to 1 to n. And the hash map can be a bit mask, I guess.
Mm-hmm.
Use of incorrect enums is impassable as they can't compile. I wondered if there was any comment about that style.
So honestly, I think we would like there to be in the language a way to do that, to say, these are my enums. And just the statement, it is impossible in my code for you to have a mammal that ain't one of these. Like, it does not happen. We would all love that. I claim that in C and C++, this is impossible because we have undefined behavior, right? At some point, you can play games or just make mistakes, and some bit pattern someplace gets interpreted as a mammal, and now that's wrong. Now, if you've got undefined behavior in your program is garbage. We all know this, right? If you don't know about undefined behavior, there's several good talks from CPPCon. They're up online on YouTube talking about undefined behavior, and they are all terrifying. The most recent one I know of, Fedor Pikas gave one, I think 2 years ago. It was only half an hour long, and he shows you how it time travels. Undefined behavior here wrecks code way the hell up here. It is absolutely terrifying. So if your code's wrong, the difference is because C and C++ let you do this, it'll compile and you can run it. But what it does is nonsense. Pascal and a lot of other programming languages, Python, there is no undefined behavior, which means you can sort of rely on the programming language's guarantees to say it'll never happen. C and C++ can't. On the other hand, C and C++ do a whole lot of things that Pascal and Python can't, right? From where I sit, the extra expressiveness of C++ and the speed and all the things you can do with it, you buy that at the cost of having undefined behavior. You can't avoid it. Chandler Carruth gave a good talk on undefined behavior, CPPCon 2016, I don't remember exactly, where he actually dives into this quite a bit. Particularly the first half of that talk is a discussion. So Pascal, Object Pascal probably gives you guarantees that you can rely on. I'll bet you Object Pascal does a lot of, or you can't do, it's the same problem Rust has. Like Rust is safe, oh, it's memory safe, it's all perfect. Yeah, right up until you do all the unsafe stuff. Right? You can still do unsafe stuff in Rust. It's just harder to do it accidentally, which is an advantage, right? But you can still do it. Why is that in Rust? Why would they have put that in Rust? Because you actually need this to get stuff done sometimes, right? You can't have one without the other. All right, let's go ahead and wrap this up because we need to get to the pub and the building probably turns the lights off in about 10 minutes. Thank you for letting me ramble. Thank you.